Welcome to Honors Physics Podcast. This is homework number 2, question number 8. We have an object attached to this lower end of a 100 coil spring, so to put this in visualization, this is what it first looks like. We have a 100 coil spring. We have the same object that's over here, mass M here, mass M here. We don't really know the mass, but that's alright. I think we'll be fine. And this is a 100 coil spring. We know that the 100 coil spring is hung from the ceiling and it stretches 0.16 meters, and then it's cut into two identical coils of identical springs of 50 coils each. That line right there tells you that the spring constant K is the same for each of these springs. So what that means is that if we have this mass hanging here, a free body diagram of this mass would show us that the force of gravity mg going down is equal to the spring constant K times x of the 100 coil spring. So then we've got those two forces equal to each other. Mg equals K times x100. And then over here we see a similar thing happen, except now we've got an mg going down. And we've got two of these forces going up. K times x50, and then going up in the opposite direction, K times x50. Right, so what that says here is that mg is now equal to K times x50 plus K times x50. And so if we take a look, I'm running a little bit out of space here. This mg here is equal to this mg here because it's the same mass, which means we can set this side equal to this side. So we then see that K times x of the 100 is equal to 2 times K times x of the 50. We don't even need to solve for our spring constant because they cancel out. And we find that x of the 50 is equal to 1/2 x of the 100. So that means that because our first spring stretched by 0.16 meters, our second springs, they each stretch by 0.08 meters.